There's common sense, right? And common sense says you have the data, you could do the research, you could create an application. Do you have to do it, right? So I used to work with the Cambridge Psychometric Center in 2012, which is 2 years before they became infamous for something happened with Cambridge Analytica. Because we said, okay, I'm going to talk a bit about those guys now. I just want to say for the record that the data is bullshit, and what they say they can do, they can't. Okay, they didn't influence the American election. I saw the data was a 2009 static database of likes. Okay, and they used that to so-called predict people's personality, which is not true. They couldn't predict it. And what they really did, Cambridge Analytica, is just get a lot of data, which wasn't illegal, and just buy a lot of cheap ads. Okay. So the Cambridge Psychometric Center had really bad data. Now, that's not the question. The question is, let's say you have the data, and let's say it could be used to influence the election. Do you have to do that? Okay, so I mean, I think independently from the fact that there's slowly a consensus about what ethics means and want to address it, there's also like just common sense, just don't be an asshole, basically. Pardon my French again. Yes. What do you think?
And the hard thing here is to acknowledge that not everyone is privileged enough to take on their organization, right? You can't getting fired from a job because you stood up for ethics and you can't support yourself. That's really, really hard. And if you talk to some people, they're like, no, just leave it till later. And what I'm saying is, you don't have to make, at the beginning you don't make a big noise. And you grow your little bit of noise. And you talk to other people and you slowly grow noise. Because that's how it works, right? You build this critical mass of people who are pushing against it. If you just come out and say, I'm going to do it, you might get fired. But if you inspire enough people around you within the organization to have an issue with it, it might work. It's hard for an individual to take on a large, giant corporate, but it's easier to do it in a slower way. And if you get there, and if you keep going and you start raising, sometimes it's even better to be on the team that's doing it because you know what's going on. This is also sneaky politics. Sneaky politics, raising it in the concerns of like users, and you do that slowly over time, and you get louder and louder, and people get louder and louder, and eventually then something changes. So it's a very hard thing to fight, and it is hard to fight by yourself. And you don't want to be dismissed by just coming out and being like, I will never work on this is terrible. They'll be like, cool, well then you don't work on this project, bye. And then you're in a place where you can't necessarily even make change. They will continue doing what they're doing, whether or not you're there. There will always be someone who's willing to do the work you're not willing to do. So like sowing the seeds of of concern in the organization and making it grow bigger and bigger. When you have enough power, being able to start standing up. Something Bayo said earlier, this was in a totally different context. It was, prove yourself to them. So start showing them here's why it's unethical. This is why it's a problem, and grow your mass. And then by the time you've got enough people on board, someone higher up is going to listen to you because they don't have a choice.
You should be talking about ethics in the beginning, but it's not too late to pull something out of production if it's unethical. You might only realize that once it goes into production, because when you see real people interacting with it and you see how it really performs in the wild, that might be the first time you realize this is creepy and unethical. So definitely, it's never too late to just stop doing something bad.
Well, I think you probably know this quite well. What about the case like with Microsoft? I think a lot of the engineers objected to the work they're doing for DARPA, and Microsoft was just like, thanks for your concern, but you're going to do this anyway. What are your thoughts on that?
So I'm not a PR person. I'm not a spokesperson for Microsoft. I don't represent them. I'm just representing my own views. So I believe that after that pressure, Microsoft did stop that contract. I know there was okay, this is off the record. I'm not, because I don't know all the facts here, but I believe it's quite normal for big tech companies to sponsor, what's it called? To sponsor American politicians. There's a special name for it if there's any Americans here. It's called like... No, not lobby. It's called like CAT or CAB or something like that. and it's I think it's cat, and it's normal in America for big tech companies to sponsor politicians, and until a few months ago, all the tech companies were giving like billions to politicians, and then they can, so if you give it to the Republican Party, they can do whatever they want with that. And then recently, I think Apple and Microsoft pulled out. They pull out billions and said we're not funding this anymore. And this is while they're trying to compete. Microsoft is trying to compete with Amazon for a massive government account, and they pull out anyway. So I thought that was quite cool. They were willing to lose business over this, so I thought that was quite cool. But like I said, I'm not an expert on what Microsoft is doing. I don't represent them.
Sorry, thanks so much for the panel so far. Just a question. Have any of you had personal experience where if something does go ethically wrong, that pushback goes to yourselves in production or those individuals working on the problem then to the PR individuals? Have you ever felt that pressure coming back to yourselves as a development team?
Always get blamed.
It makes up a very bad inequitable conversation after that with your family.
Why have you?
Yeah, have you? I'm interested to hear. That's
No. I was just wondering at larger companies.
No, I haven't personally experienced that. That must be really tough. Who takes responsibility for a bad ethical decision?
I would refer back to what's his name, World War II, and what they did, and actually Ruha's talk where they split the bits up so much that no one felt individually responsible for any one or thing. And if you ask people from World War II, they said I put people on trains and I sent them to where they were meant to go, and that was my job. I was doing my job, so it was okay. And yeah, it will come back to bite us. It probably, I have heard of it coming back to bite the developers, but it usually, in the structural world, people do take it higher and say, no, someone else should have done it. But I do think we should take responsibility. We should have the ability to start speaking out and spreading the little words. I haven't heard of anyone where it's actually come and hit the developers and they got fired. If that's helpful, if you're worried.
No, I haven't experienced that either. Only the Cambridge psychometric one, as I was saying, awkward dinner table conversations, but that's pretty much the extent of what I had to pay for working with on that project.
Okay, nearing the end now. So I'm feeling frustrated that my PhD did not prepare me for how to get my ML models out in the world. Did I miss something? So I think that's not...
It feels that way.
Does anyone currently feel under-equipped to actually put something into production? Yeah, so I think, maybe some PhD programs do teach you practical skills, but I think a lot of them are just very theoretical, even from great schools. So there's nothing wrong with your university. I think that's probably most universities. But I think something Jade and I were talking about earlier was that, and I think there was this massive hype wave of hiring data scientists. And after a year or two, the business students are coming back and saying, so what have you guys done in the last year? Oh, you've got 2 notebooks. Okay, that was not a good investment. They want to see what is in production. So teams are actually starting to be a little bit more accountable. I think maybe the golden age of being able to do whatever you wanted are over. And there's more accountability now as the rest of the business wises up. And they're you haven't actually added any business value with your notebooks, so it's time for a reckoning. I don't know, you guys seen that?
I have. The one thing I wanted to add here was, did I miss something? You didn't miss something, everyone missed something. I come from a complete software engineering background. You think I would have known what to done, at least from the software perspective, on some of these challenges. And sometimes you look at all these great giant tools. The amount of time I spent fighting with these CI tools and these DevOps tools, and just being flabbergasted. We've got some of the most senior engineers in the team being flabbergasted. So if you're feeling oh my gosh, there are all these tools and there's so much stuff and I don't know it, it's okay, you'll get there. Just pick one and start with it. It's actually not as hard as you think it is. It's just a little bit of a fight. And if you're fighting and you're feeling like an imposter, everybody is, because no one actually knows how to do this in like a step-to-step way. That's why this wasn't a step-to-step talk. We can only give you like a recommendation. I think alone we are all very unequipped, trying to talk to as many people, and that's why having a good bond with your engineering teams and learning from them and teaching them is like a good way to like start growing that, because they've probably had some of these fights before.
Yeah, and to add to that, the tech stack moves so quickly. That's why we didn't want to give you a list of like, this is what you must use, because it'll be outdated next year. So it's this constant frustration of like, oh, that tool I was using is now being overtaken by something more efficient and more wonderful. So that is frustrating, and you constantly feel like you're missing out. And this field is really new. Software engineering is developed and mature, and there's a set of practices just like the rest of engineering. Like, you don't just go and build a bridge without some regulation and testing. So software engineering is a bit more mature, but machine learning is just like Wild West when it comes to production. So I don't think there are industry standards and practices. It's something that is currently being defined. So actually, if you're interested in this area, it's wide open. Like, if you want to suggest the best way to put stuff into production and to collaborate, it's people are looking for answers. Yeah.
Yeah, and we have like half an hour. So that, yeah, about 10 minutes at last one, and then we got 10 minutes.
So we could do some.
Just 2, 30 minutes.
Is the other speaker around?
Yes, Brian, are you there? Oh yeah,
Okay.
cool. Yeah, we should probably wrap up so we have time to listen to terrible and creepy, horrible mistakes and just nice challenges that people had at work. But first of all, maybe we can take just a couple of questions and then, yeah,
Any questions from the audience?
a question there.
Do you want to?
I'll repeat it.
Yeah, the question goes on about, as you say,
Getting a mic.
My question just relates to some of the last comments you had about tech stacks. The field moves so, it's very fluid, it moves very rapidly. When do you know that you should actually move on versus keeping the stability of your current stack? What would you say is a good metric for that?
That's a very good question. So the trick is, I believe we develop stacks faster than we could ever keep up. And I think leaning on we're doing okay for now is good. So like in our projects we regularly do this. Like, I think we've written our current stack 3 times, but not just the ML stack, the entire app 3 times over the years. And for us, if what was important was keeping up to date, but not necessarily putting it in. And it's sometimes good to know what you're missing out on. So usually those new tools solve like a really big problem. So that's the one aspect, is like, look at the new tools when it's solving something you can't currently solve. That's a good metric to use. And the second bit is, like, I would always say like a couple of years, because things can completely change. But we can't change every year. We'll be rewriting too much. But at the same time, we can't get things to become legacy. And there's still things that are supported now. So my system, I don't use Kubernetes because I never needed to. I use Docker and some Travis, and that's it. And for a long time, we weren't even using that. It was a simple stack. It didn't have to scale that much. And I think that's okay. Don't just run to the new tool, because Kubernetes sounds like the greatest thing in the whole world. It's a big learning curve, right? So yeah, so there is a bit of a balancing act. And I'd say, yeah, when 10 years is too long, 5 years is probably too long. 2 to 3 years feels like a good time to pivot. By then you've added a lot of value, and you're seeing progress. But definitely don't try to keep up with the latest thing. Like, stability on a production environment is important. So when you can add more value and that value is worth it, then switch.
Another question, or should we move on to terrible nightmare and catastrophes?
One more here. Okay, so I've just finished my bachelor. Okay, I know how to build models, do the math, do the stats and stuff, and so I have my Colab notebooks and stuff. But then when I'm applying to jobs, you find those weird requirements. They want you to do data ingestion and warehousing and, do those pipelines and designs, all of those stuff on the side that comes before and after your model in the lifecycle production. So my question now is, should I focus at this point on learning those weird stuff? Or should I just keep, or invest the time on enhancing my machine learning and AI skills?
Maybe I can answer that because I've had some experience dealing with exactly that kind of problems. I would say 70% is about knowing how to think, and 30% is about extremely applied, super fashionable stuff you need to know right now. Especially in engineering, right? So solving problem is solving problem. There's ways to think about a problem. It takes a while to understand that, so that's why it does like this whole AI machine learning intellectual exercise. But then, to your point before, you do have 2-3 years studying, right? So within those 2-3 years, it's probably a good idea at some point toward the ends to start looking at what's trending, on GitHub and stuff like that, and just get a general idea of what most people will actually be using in the past 3 years. Most people who write job descriptions are not tech people, and they have no idea. They have no idea. They just copy-paste it from somewhere, and they have unrealistic requirements. We've actually analyzed the amount of occurrences of stuff that really shouldn't be there. There's just it's only outliers, right? You should know Kubernetes and Photoshop, and I don't know. This is no, and so I wouldn't be too impressed about the shopping list. I think that, look, you've learned how to think. That's the most important. You've made yourself aware of the latest trends, so if you work with other engineers, those are probably the things that they most likely will be using broadly. And probably in terms of selling yourself, I would say, look, talk to anyone, just call them, okay? Just don't send your CV, just call people, go and meet them at events that don't actually read your CV. Call them directly and tell them, I have 60% or 65% of the skills you've listed on the CV, 20% is unrealistic, the other 20 I can learn within a year. When do I start? Something like that.
Okay, so I'm a machine learning engineer at BDestiny Technologies, and the main motivation of this talk is just walk through different kinds of things that you'll end up experience as you work on in a machine learning team. So a quick question, how many are students? How many have started working as software engineers or machine learning engineers? Cool. So we have 40 and then 30%, so the rest are already further along, right? So my background is as a software engineer. I worked for consultancy where we built a tool for mapping rhino conservations. And then I moved on to healthcare informatics, where I worked on terminology services. And then I learned practical machine learning while working on search problems. So the idea is you want people to be able to use a search engine very easily, and you need to be able to rank data in a very memory efficient way. Most machines have low memory that we're interacting with, and they just needed to have high usability. So after learning all those things, and then I ended up joining Utu as a machine learning engineer. This is a log of my experiences. Maybe this has been a year since I started working as a machine learning engineer full time. So this is basically just looking back on the past, what's happened. I think many of you will end up shaping machine learning systems, and I think these are things that maybe you end up finding useful. So as you work on team, for example, let's say you join a company and you find a company in a particular state. The team is trying to solve a problem, say logistics, for example, trying to optimize shipping packages from one town to another, right? You find them in a particular state of development, right? So your interest in your project, actually one of the main parts of your project should be figuring out what your team's priorities are and what the priorities of the other teams you'll be interacting with are, right? Because what that means is that you the more you talk to people, the more you understand what things are hurting them the most. Because when you start out, you might think that you have a handle on one thing. Let's say your analytical skills drive you towards, let's say, image classification or image recognition or NLP, for example. But the problems that the team is going through have very little to do with that and have something to do with something that is slightly adjacent to the problem that they're actually trying to solve. Right? So the question for you will be, who's in your team? How do they work together? How do they communicate with each other? Which tools do they use, and how do they see the data that they generate as employees and as workers in a particular project? Now, if you see a system where you've worked on, you've solved a problem where you're actually trying to be in a group where excuse me. So if, for example, you've gone through this whole step, right? Process of understanding what the team's priorities are, right? And you've worked on different parts of the problem, you've prototyped and you've tried to understand what's going on. Then you, as an engineer, as a machine learning researcher, you'll have several kinds of challenges, right? One of them is when you're training your model, when you're running, once you train your model and you've actually built and you've actually shipped a production system, how do you infer, right? How do you how many times does a request get sent to a server in order to get multiple responses in inference for predictions that you need? So you can either do it once in a batch, let's say, or your system grabs 5 or 10 images or something, or 5 or 10 requests and serves those at the same time, or you can have a system that just serves one at a time. These are questions that are important for you because you, pretty much any time you're running a system in production, you're going to have memory limitations. And usually there's a quality difference in the data that you have available to you. So an example is if you've worked on an academic system and let's say you've worked on data that was published, most of the time you will get data that is very clean and very academic and very nicely organized. If you're not doing that yourself, you'll find it and download it and use it like that. And the thing is, there's a very big difference between that and a scenario where people are actually using your product. Say it's an app people are using to take pictures of plants in order to get disease classification. There's a huge difference between a data set that you might get from an academic community and what you actually get in the real world, because when people are creating a data set for a leaderboard, for example, the quality that they have will be determined by the number of people they have in the team to collect the data, which means you'll get a very small number of high quality images, right? But in production, out there in the world, there's a wide range of phones, there's a wide range of devices that are getting this data, which means there's a huge difference in the quality of images, and that causes a very, very big difference in performance. So you might have a system that performs extremely well in notebooks, but just performs really poorly once you go out to the real world, because the domain is very different. The way to solve this is to basically use techniques like active learning, where you always keep track of any prediction and you always keep track of feedback from users. And I guess one other way to solve it is to go back into training more models by doing things like domain adaptive learning. Another problem that new teams go through is when they're interacting with data and it's sparse, right? How many records do you have? How many of those records are fully represented? What do you do when the data that you have available to you just doesn't cover the problem that you're trying to solve? And if sometimes the problem might be somewhere else. So, for example, if your team one of your team's goals is to say ship a particular part of the product because it's in the marketing language of the product that it has to have AI, but then the project you're building doesn't actually need it at that time, right? You'll work on things that require machine learning, but then it doesn't actually fit the product, and the product isn't in the place where it can actually make the most of it, right? Yeah. So what this causes is a big difference in team priorities. So if the machine learning team or the team that is working on those problems is focused too much on that, they won't do the things that actually help the team get to where the machine learning problem will be the most useful. So I think most times when a new machine learning team is built, so if it doesn't take into account the product path, then that almost always happens. So that's why you end up a year later with almost nothing done because the priorities just don't match. Right? People start out thinking of a project or a problem as an academic scenario, but then there's actually efficiencies and inefficiencies going on in the rest of the company. So, which is why earlier it's like your main priority should be to understand everything about the team. Right? The data will be there, and it changes at a rate which is determined by the team's workflow. And if the team's workflow is hampered by them needing to go back and fix problems individually and manually, that could be fixed by, I don't know, some data visualization or some automation somewhere, then you'll find a situation where more and more money is being spent in one direction, which is a direction which will never be made efficient at all, which can be fixed by just changing some few things in the process. So, say some of the things that one might find that are interesting. So, before you introduce a machine learning system, for example, or before you even introduce a design change, and if you're in a scenario where you have a few thousand users or a few 100,000 users, the best way to understand what the effect of your changes is, other than the design plan that you have, other than the project plan that the team has been has proposed or has built, is to understand how people will react to the changes. Right? And the way to do this is to understand the population of users that you have. So this is called A/B testing. Right? So the idea here is you split your population of users into different groups, where you make single specific changes. They don't have to be single changes, but they just have to be meaningful changes to assist how the system works. So, for example, if you want to introduce a machine learning pipeline into a product that you built that is active, that actually has active users, the best way to find out whether it actually helps people is not to shape the machine learning system to the whole population. Ship it to a small group, see whether it improves their workflow, and then ship it incrementally to the rest of the team, so to the rest of the population of users. Another thing is when you think about the products that you're building, it helps when you think about all the systems as separate entities. So if you have a server that takes requests from people, let's say it's the back end of a single page website. It should be completely decoupled from a machine learning model if it's introduced, right? Completely decoupled, so that you can log all of the requests to it, and then you know exactly what people actually finding problems with. This helps with getting user feedback as well. Right? So if you know that one user made a specific request and they got feedback and they gave feedback for that particular request, then it helps to know exactly what those things are. Then because that's the data that you will need to retrain the model when the time comes. And there's a rate at which you will end up retraining your system, and that depends on your users. So if you have the system you're building contains records and records and records. Then and people are uploading data. Or an example I like is in GitHub. So I think they retrain their model at least I think twice a week, right? And that's because of the sheer number of people who are uploading and using repositories there, right? So, and this all depends on the rate of data input that's coming in, right? And so it always makes sense to think about how often you're going to do that. And it always makes sense to think about that as upfront and say, okay, when you're working on this system, you need to realize that there's so many things that you need to automate before you get to the point where everything you're doing is just a matter of deploying a new model or something like that. There's data pipelines, there's data ingestion problems. You need to think about data warehousing, for example, and all this matters based on the problems that your team is trying to solve. So it always starts from understanding the company that you're working at, understanding the problem domain, without thinking about modeling. Your role, rather the skills you have, the only leverage they give the company is when the information that people have accumulated within the company actually helps you make decisions. Right? So people try and make informed decisions, but then I guess the project, when someone is starting out, is to learn from each other. So there's a priority order, for example. So you can't solve all problems. You can't solve all problems at the same time, and your best bet is to listen and understand what the team's priorities should be. So, which I guess now goes to the domain, right? The problem that you're actually trying to solve. Right? If you're in the process of training a model, or if you're even deciding what the model is going to be about, all of the questions you should be asking should be about what metrics of the business are represented in the model you're training. So, an example is if your model is about disease classification, for example, you could figure out how many, it should maybe about a region, right? One part of the country is affected, and you don't really know the numbers there. So the idea is you need to figure out a metric that matters, so that you can organize for the rest of the team. And finally, we have visualization. So this is one of the most high leverage things you can do when you're starting out. All of the data that is generated and is stored in a system that you have access to can be visualized in some way, and it's almost guaranteed that there is one or two ways that will just help you, right? It won't just help you as a machine learning engineer or as a data scientist. You can find ways to visualize data that can transform the productivity of the whole company, right? And this basically usually depends on the problem. So an example I have here is a system called H3. It's a hierarchical indexing system for geospatial data. It's one of those things where it basically gives you a grid for grid, and so for a map it gives you a hexagonal grid, right, of locations based on something that has happened there. So this screenshot is from a notebook which shows how to shows how to cluster accidents in the UK. This is extremely helpful, not just for one person, for one group, but for example, if you're working on a logistics team, you can build a system that contains this as a feature, but it won't just help the engineers. Right? This is something that can actually be used in the logistics team and actually help people work together, actually help people communicate direct problems with how the system is working. So thinking cleverly and thinking very clearly about ways you can see data, it's not just about visualizing your hyperparameters. It's not just about visualizing training progress. Like you have access to so many different ways. And a good way to start is to maybe look at a book by Edward Tufte called Visualizing Information. So when you start with communicating information, then your understanding of the team's problems and the team's understanding of your work will grow much further. So I think in addition to I guess some of the basic requirements of the team that one mentioned earlier, like the team doesn't really care about notebooks that you've made and stuff like that. What they care about is like a pickle file or something, or a pickle file or a Flask server. Like another thing that they can grow on is meaningful visualization, right? Because the meaningful visualization can transform how an organization works. It's like one other way of effective communication. So and that's really the foundation. If in a team of 1,000 people, there's 2 to the 1,000 different communication channels. And if you have one way to communicate that works well across departments, then you don't need to have so many people having meetings and having weird, random, long-running discussions when you can just look at certain states of the data. So, thanks.
Hi, everybody. So I don't have any presentation. Kenyanju is my name. If I talk really fast, ask me to slow down. And I'm part of the data science team. I'm a data scientist, but I've never acknowledged that. The reason being is of imposter syndrome. You know that. And so, but I've had the opportunity to be part of the team for about 2.5 years, and this is at a local telco called Safaricom. And so we've dealt with a couple of interesting problems, and basically I'll be here to narrate stories of how we've faced different problems. Sorry about the people this side. We've faced different problems, and when pipelines crashed, what did you do? And basically, moral of the story is that you still live. No one died. I'm still around. They haven't fired me, and that's a good thing. It's at that point in time, you're a bit scared. But based out of the teaming, we work like consultancy teams. So different business units basically engage you to come solve the problem that they have. So be it the financial business unit, they're like interested in something to do with M-Pesa, you come show us some of what you can possibly do. So, or be it the call center team or whichever team it is. And so within the team, we have different individuals who are supporting the different business units. And but as a team, each one of us is interoperable by the fact that we all know where we are at with our projects and even the problem and how we're solving the problem. So that's basically about the team. But one of the aspects is that we've gone through this journey of how do we bring this organization in appreciating machine learning and AI and how some of the problems. One of the things that we've come to observe is that they have their own understanding of data science. Totally their own understanding. And this is from, remember that Economist article where they're like, yeah, data is the new oil. Data is the new oil, so they're very opinionated with regards to that. So they're like, it should look like this, it should be like this, and that's one of the aspects that emerged that we're faced when we're engaging with the different business units. But the first story I want to start off with is of a product. It was a discounting product where we're offering different discounts to different customers. So think about your telco stack. You have data, which is MBs, right? Megabytes, so which you're selling the data, you're selling the airtime minutes, and you're selling voice and SMS, right? But you're doing this in a very targeted and personalized fashion. So it's like each individual has their own personalized offering, and you have to do that. The best way you can achieve that at scale is through machine learning, definitely. And so here we check in. We've already trained the model, and these guys are like, how much data did you use to train? We're like 600,000 customers, and really, okay. And they go like, oh, serious? That's quite a number. Can we scale up to 1 million? We're like, yeah, we did 600,000. 1 million should not be a problem, right? And so we had already done some ingestion pipelines in order to extract the features. And you know the classical problem of features. So a feature is, remember your bank statement. Your bank statement is like in pros form, like your many line item issues there. You can't just run that into your logistic regression or random forest model to actually do a prediction. Instead, you have to create different features out of that. So it's like, when is the last time you either called somebody? When is the last time you either sent an SMS in the last 3 months? How many people have you interacted with via M-Pesa in the last 2 months? So those are features that you create from that long statement that you have. And so this is our pipelines, and classic me, Mr. Select Star, which is basically inefficient queries because you're not a data engineer, so you haven't optimized your queries. You go run those queries at around, I remember it was I think about 30th March. It was on a Friday, 30th March. So it was Thursday, Friday evening, because you're nocturnal, you queue these queries at around maybe 2 a.m. So this was like 60 queries all at one go, and you go to bed across 1 million customers. You wake up in the morning, you're like, things are okay, I'm not even checking what's happening, I'll give it like 12 hours. So as soon as I get to the office, I get called by somebody who's like, wait, what are you doing with the database? So I'm like, I think it's a different database, because you interact with multiple projects. I'm like, I just got access yesterday, so like there's nothing I've done. No, your name is there, and you've already locked the temp space. The reports are not going through. So at this point in time, I don't know which database. So I'm like, let me just enter. I go to my desk. I get into my desk, I see a barrage of emails, like literally emails of people going like, Njoroge Kinyanjui, and they pull out. So the problem was that this database warehouse systems that we use, and the moral of the story is that the warehousing systems that we were using at that point in time basically allocate temp spaces for every query, right? So you run a query, it allocates a temp space. So I've done 60 queries, it is pre-allocated, but it's not releasing because there are multiple jobs, right? And the time when I ran for 600K, it all worked, right? But guess what? It's end of month. It's 30th of April. It's March, 30th of March. And so the end of the month is end of month reporting. And so there's also different aggregations that are happening within the database. So I am being accused that the daily report has not gone to the executives. And it's because of this guy was running his queries. And so they go like, wait, we're canceling all your queries. I'm like, okay, that's okay. If they haven't gone to the executive, do that. But send over your queries. So I send over my queries, and you can imagine the amount of insults the data engineers actually have. So this is somebody who's optimized the warehouse, and the amount, they're basically saying this is inefficient queries, the most inefficient queries I've ever seen, and you're doing this like 10 of them. Not just 1, 10. Who taught you? So, so literally, when I went back to this data engineering people, and they got and I had not met them. This is the warehousing team, and they go like, that's Kinyanjui. Like literally everybody turns their head around, that's Kinyanjui, like, because of the amount of stupidity that they've done. And so there's always a running joke that come every end month, like now, like my name has to be blacklisted, so that you're not queuing different queries. And that's the first bit, which is moral of the story is like, get your ingestions right. But I think the thing that we should have, and we're still doing now, is create a feature store. So Uber is a brilliant feature store that they talk about. And basically a feature store is, remember those statements? It's interoperable across, that feature that you're creating is interoperable across different projects that you're using. And if you're able to deal with that problem, your ROI as a data science team literally dramatically shoots up. I kid you not. So those inefficient pipeline queries that I run, remember there are scripts that I just change one table name and I'm able to do the same job across different projects. But if we're able now to standardize this across board, then it will mean that the time that we take before we're able to get to our first prediction will literally take nothing less than at least 2-3 days. Because your features and your data story and nonsense is done. The second story, now this is down to the business. So again, given that this person has a probability of defaulting, how much money are you willing to lose if you're trying to minimize your losses? So given all that, we come with a figure. So we come and say like, this merchant actually should deserve 10,000 shillings, this other one deserves 5,000, this other one deserves 500 shillings. And we go to the business and they're like, give me for this select individuals, which now the problem starts coming in. So everybody comes with their opinion, which is, and my colleague here actually remembers, everybody comes with their opinion of how much each business should actually have. So it's like, think of it like, how much do I deserve as an individual? And since everyone has an opinion, it becomes really nasty. And I remember when it became horrible this Monday morning, where we've given them the limits and they're like, how is it that that business is transacting all this amount of money and you're just giving them 500 shillings? This score is bullshit. And you're like, okay, all that work that we've done, that goes. And only until we had to now, and the benefit for us was that we had to walk them through from the understanding, which is like, show them the counterfactual approach. So which is like, why is it that they're thinking from that perspective? So we show them now the WE regressions, which is basically we regress the dependent variable with now the feature that they're talking about, which is, let's say, somebody's amount of money that they've been having, and show them that relationship to default, and prove to them that what they're thinking is actually wrong. And that way, we did that for like 2-3 days, only until we eventually went to present to the director, who was like, yeah, this is such a good job, but in fact, can we lower the limits? And everybody just looked at them, at us, and were like, oh, you were right the first time, so you actually did a good job. But the major thing here is the backlash. The problem is there's a disconnect in understanding, proper disconnect. Go try to explain bias and variance and why your data is crap to somebody who they've actually been doing this particular business for quite some time. It's a real big problem. But the benefit of the doubt is that you can actually change, you can actually help them, is you have to stop using words like algorithms. Sorry, I'm a bit sick. Stop using words like algorithms, models, whatnot. That's nonsense to them. As far as they're concerned, it's ROI. And instead, you want to now analogize, like bias is the fact that, you see, if we model based out of this room, right? We collect everybody here and we're saying like, okay, we used the features based out of everybody in this room. We cannot be able to generalize across the other side. Then they get an intuition of how that could possibly be at that point in time. So with that, I had a third story, but I'll kill it. But with that, I'll leave it to questions, if you have any questions. Yes, they have not kicked me out. We're still there. And that with the last story about the business is stick to your guns when you know you're right. Yeah.
It does happen.
Yeah.
Hi everyone. I think from Kinyaju's story is very sad. Like at times you had to, as a data scientist, you have to like brush shoulders with engineers at some point. So my question is, how good is it for a person to stick to their line, like major in your work as a data scientist and collaborate with a data engineer? Or how good is it for a company to employ someone who has both skills and they have them at a lower grasp? Thank you.
So I think within our team we're very fortunate. So in that we are people from CS backgrounds within the DS team. So we have a colleague who's like a ninja in. He sits as a data scientist, but is literally a ninja in dealing with like optimizing jobs. Like we've been able to do some very interesting things like network related. If you think about network related problems, relatively empty hard problems, and out of that you need to rely on software engineering like skills for that. Your DS skills of like R and Python have basically, unless you're using Python bindings on Spark or something, are relatively, will hit a peak at one point and your compute will just tap out. And so out of that, the early stages of any DS team that's forming, you rather have blends of people who come from backgrounds that are either able to communicate to the business while at the same time engage with the DS team practically, basically they're working, and while at the same time be good software engineers or have some experience in software engineering. And for us, it happened by accident. Because we're left in the dark. We're literally left like, here is a server, you're done, I've given you everything. Here's a database, connect to it, I've given you everything. As far as they're concerned, they're expecting an output. And so it's either you come back and you start saying like, I don't have a data engineer, which they're not willing to listen, and or you start figuring it out. And so there's a colleague of ours, he comes from an applied statistics background, and he is really good in servers, like now. He learned servers like literally a year ago. And it's taking that initiative to learn. And if you're really interested in productionizing what you have, you'll figure it out. Us guys in productionizing, a lot of it is, it's a question you had asked. It's the stack is, think of it like we have legacy stacks, right? You're either communicating to a system either through two ways, which is an API or a database that you're writing. And so that's the major way. So if you want to design something to scale, as how we're thinking about it now, is that the systems, we're already going to a microservice architecture, so you might as well just design it from an API base. So if you can do end-to-end, deliver it as an API, and your data source is just something that you do as a call, hopefully cached, then now you're able to service at scale because you're scaling horizontally. I think if you have the ability to build on a new stack, build on a new stack. For us, we're constrained by the fact that you have to communicate with systems that are a bit old. Yeah. I think that's it.
Right.
Oh, no question. Right? People are hungry. I'm looking at people's faces.
There's no food, nowhere to go. It's stuck here. Sorry. Maybe in 5 minutes.
Okay, so the third story was feedback loops. So the bit is, once you're in production, yes, you don't have all the best thing you can do for yourself is monitoring. And so going back to that problem where the pipelines crashed, remember that one? So we fortunately were able to get it running. That ninja of our data scientists that work with, called Anthony, optimized some jobs that were running for 6 hours to be done in 5 minutes. We're like, oh, that's how inefficient I am, you know. And we're able to scale up. Fortunately, we're able to scale up, and we scaled up to about 2 million. And only until now we're like over enthusiastic, and we're like, we need to optimize. And it's something that we haven't really cracked, which is like, how do you get a viable A/B tested stack, because it's very customized. You're testing one bit of the problem across your full chain. And so this is something that we're like testing. We wanted to test out a different model. We wanted to test out a different way of pricing, so that we can cut off some groups of people. And so what that did is that it resulted now into everybody, a whole bunch of people not having any offers or not having any propositions. So when we wrote into the database, so as far as we're concerned, we get an SMS saying, yeah, the database has been written. So that's a monitoring that we have at that point in time. And the next thing that happens is that you move on to the next cycle, which is, once you get your monitor, which is now it's served the next day. So basically the customers will see that particular offer that you recommended the next day. So once we've done that the day before and they're serving the next day, as far as we're concerned, it's good. Guess what? It's a Friday, so people go. And since we don't have like dashboards that are live that you can actually see, which is the mistake that we did, is that we had not presented offers for people, and so that lost about 20 to 30%. Yeah, that was a significant amount of money across a group of people. And we come Monday, we look at the numbers, it's like, my goodness, okay, here we're being cooked for sure. And true to it, we're cooked. And what they did is they scaled down the number of customers that we're working with until we've been able to optimize efficiently, which we're still doing until today. Yeah, it happened like recently. Yeah. So the moral of the story there is, get your reporting right from get-go. Like, you found much better to not deploy until you have live reporting, or at least live reporting. For credit, it's different. For credit, you need to have drift. You need to monitor your drift a lot. So for us, it's like we need to see who's coming in for applications, and that's That's like if you're having a different segment of customers coming in for applications, then now you have now a problem which is exposure of portfolio. But that's different. But now mostly just get your monitoring right from day one. Don't assume that it will be done, or don't rely on the analysts, the analysts to do the reporting for you, which will send you as an Excel sheet at the end of the day.
All right.
Yeah.
Thanks a lot.